Hi and welcome to this tutorial. Today I did a model of the dynamic compression test over composite column. The core is ultra high performance concrete. The cover is a steel column. We have a steel angle reinforcement here with a stiffener. A bed steel plate. This is a thick bed steel plate and bolts the connection between the concrete foundation and let me now consider this. We have a steel reinforcement and a bolt in the concrete, and here this is a normal or typical concrete. If I click on this, see the deformation. Here we can see the deformation here. Let me remove the rigid body, see the deformation here, and now let me replace just the concrete, the ultra high performance. Here is the stress. Then we can check the compression damage, tension damage, stiffness degradation, or displacement. Now let me replace the steel column. See the steel column, and this is the compression uh, animation. You can see that. This is the compression test. We use reinforcement, steel angle, and stiffener at the bottom, so we have a strong zone here. This is the stress. Ductile damage happened here completely, so it means here is failed and stress. And now let me remove these parts here and just replace it here. See here we have, let me use a limit, for instance make it 2 to have a better view. Click on animate. This is the stress propagation in the stiffeners, bolts, and a steel bed in interaction with concrete foundation. Okay, let me use feature edge, it is better, and let me use 5 as the, see that here we have the formation. Okay, now let me use auto selected, replace just for instance this is the steel bed. Now replace the bolt, see the stress in the bolt. The ductile damage, we don't have, the bolt is a strong bolts. Now let me replace the concrete. Here the concrete, this is the stress, compressive damage, tension damage, and the stiffness degradation in the foundation. Now let me replace here. See that the steel reinforcement also experience the strength. And if I draw a force displacement diagram, you see this is a force displacement diagram for this model. Here is the peak, then we have engagement, it is increased till here. Here we have a decrease in the force capacity. If we keep the displacement or load, it will reach as zero value for the force, and it means it is failed completely. You can see it here. Now let me replace for instance this steel angle. Ductile damage, we have a little bit. Plastic strain, we have displacement 1.5 millimeter, and this is the other results you can check. See, click on this, you can see this is the stress, and this is the comparison. Local buckling at the middle happened, it is obvious, and this is the final result. See here we have the formation here. Okay, so this is the full model of the concrete column. ultra performance core with a steel cover, steel angle and stiffness, bolt, steel bed, and concrete foundation. You can change anything from this model. So if you need this tutorial step by step, you can come to our website here, abacusfem.com, here www.abacusfem.com. Find the English tutorial here, click on this, then you will have the title, geometry, assembly here, then the step, material, interaction, load, and the result as figures. Uh, you can provide CAINP and English video file step by step, and you can use a PayPal account, Visa or MasterCard for the payment. Before that, contact me to this email to provide this original tutorial. Our website provide original tutorials rather than the other website use the copy tutorials. So if you want, you can also provide our full package contains more than 400 tutorials about all aspects of simulation and modeling in Abacus. Explosion with 4 method for all the materials. Impact, high and low, welding, biomechanics, forming, crack, source, CFD, anything else, anything. And the cost for that is so affordable for all people. Just contact me to this email, then I will answer you about the content of the full package, about the price and the payment method. Just send me an email to this address. Thank you for your attention.